Привет, Sam. How is everybody doing? Excited? Sleepy? Did everybody get their popcorns? No? All right. Thank you so much for attending my talk on web-based multiplayer games with WebXR. Today, I'm going to tell you a story, and this story is a compilation of many different experiences. Some of them include my first experience with virtual reality, the challenges that I faced, why I felt that WebVR was the right choice to make, my love story with A-Frame, and various other experiences, experiments, and thoughts as a result of which I created a series of demos. So this story will take you through a journey where we will learn various things and learn to leverage various possibilities and components to create your own multiplayer WebXR game. So this story does have a slight element of nostalgia as we will be using the Pokemon universe for our demos. So let's get started. Yes, that's me, despite of the little resemblance. My name is Tanay Pant, and I work as an operations analyst at ResearchGate in Berlin. I'm also a part of two really amazing programs within Mozilla, the Tech Speakers program and the Representatives program. So those of you who want to know more about it, feel free to catch me after this talk. I'm also an Intel software innovator in the field of IoT and have published books on Firefox OS, building virtual assistants on Raspberry Pi, and web-based virtual reality. And of course, I love Pokemon, but we'll talk about that later. That's my Twitter handle, and I'll be sharing the link to the GitHub repo where I'll publish all the demos that I'll showcase in this talk. So make sure to watch that space. Last night I was debating whether we should do this or not, but it's the first talk of the conference. Many of us might be feeling lethargic. So let's kick this off and jazz up the energy in this room by doing what I call the open web stretch. So bear with me for a few minutes. May I request everybody to stand up on their seats? Just take a few minutes. All right, so this is how the open web stretch goes. So first of all, we reach up to all the upstreams. Then we bend, go down to reach the grassroots. We come back up, we blow the winds of change. We put our hands on the front and shake the money tree for fundraising. Give it a good shake. We lean left to avoid the NSA. We lean right to avoid the FSB. We go all around to avoid both of them. And we are done. Thank you so much. Please take your seats. So, how many of you have had any experience with virtual reality before? No? Maybe heard of virtual reality? Okay. So my first experience with virtual reality was when one day my father got me something called Google Cardboard. And it was quite interesting to me because he just took his mobile phone, he installed an app on it, put it in the cardboard, and it worked. I particularly remember not having a really great day at that time, probably because of my exams. Anyways, it transported me to a different place, and it was quite realistic. I was suddenly on a roller coaster, and it was spectacular. It was love at first sight for me. And as time passed by, I did learn that virtual reality is not just useful for games or entertainment, but it's also quite useful for other purposes as well. So if you're an engineering student, it really helps to kind of visualize the 3D models that you create in CAD or AutoCAD in a truly 3D space. If you're an artist, then you can use Google Tilt Brush or A Painter to kind of paint in 3D space. And not so long ago, Samsung created a demo which helped people with acrophobia, that's the fear of heights, to safely stand in a simulated environment, which kind of simulated a high-rise building. And this basically helped people to overcome their fear in a safe and controlled environment. And that really resonated with me because I myself have a fear of unguarded heights. And if you ask me to get rid of it by standing on the edge of an actual high rise, I would be pissed off. So this shows how VR can be used for the enhancement of mankind as well. So time passes by and I'm now in college. I have all the free time in the world and I decide I'm gonna make a VR application. And by that time, there were quite some VR devices, and each device had their own SDK. And the size of each SDK was in gigabytes. Are you kidding me? Gigabytes. I had a quota of 1 gigabyte per day in the college I was studying, and it was not exactly well known for its bandwidth or capacity of that. So if I did manage to make an app, I was quite doubtful that people would actually download it or install it on their devices. And these SDKs did have a steep learning curve. And before you could share that with your friends, it had to be approved by the app stores. And they acted as a gatekeeper. And there were just too many points of frictions, and it was demotivating, especially for a freshman student. Then one day I heard about WebVR. What is this? Can a browser even display graphics at a good enough rate to match performance of native apps? I was skeptical, but then it did make quite a compelling case. It was open. Anybody could publish anything on the web because it's the web, of course. Different VR scenes could be connected with each other by the means of hyperlinks or portals. And one could have instant VR experiences. One could just send over the link of their VR scene to their friends over Telegram or Facebook Messenger, and the person just has to click on it. No build steps required. This indeed seemed like something that I would like to try. Moreover, I already knew web development, so it just required HTML, CSS, and JS. So I thought, let's give this a try. I was really psyched. I was going to make my first VR application, but then I learned it's not that easy. There's just too many moving components to handle. Have any of you used either WebGL or 3JS here? Oh, that's a good population. So these two are like really crucial parts of making a WebVR application. And if you have used those, you would probably agree with me that they have a pretty steep learning curve themselves. You would need to install VR effects, preload assets, initialize the scene, set up lighting, camera, take care of responsiveness, canvas. I did not want to go through all this trouble just to create a small prototype. And there's a lot of boilerplate, as you can see. And all this code would need updating with new version of libraries. And if you haven't dealt with that before like me, then you'd be less likely to create your own Hello World VR scene with this. At this point, I'm really close to abandoning my dream of creating a VR application. And my exams got started in the university, and after a month or so, I think I came across something called A-Frame on Twitter. So apparently, Mozilla started a new team called MozVR, which was working on developing this framework. I thought, okay, let's give this one last shot. And A-Frame basically is a declarative framework for building virtual reality experiences on the web. Fair enough. So I just started to go through the examples it had on its website, aframe.io, and the documentation, and I must say I was quite impressed. It was designed in such a way that it really made it easy for web developers to work on WebVR without any prior graphics knowledge. And it definitely made prototyping and experimenting much faster. And it was basically the perfect vehicle to kick off the WebVR ecosystem. So this is a Hello World program in WebVR written using A-Frame. As you can see, it's just HTML, and you can start by dropping a script tag, and there are no build steps required. One line of HTML, a scene, basically handle all the components like canvas, camera, renderer, lights, control, WebVR polyfill, VR effect. And for further development, we put our stuff inside a scene. So let's take a quick look at what we have here. So we have different primitive geometries included in the scene here, like a box, a cylinder, a sphere, and they have their own attributes for defining position or rotation in X, Y, Z coordinates. Now, A-Frame is an entity component framework. Have any of you used Unity before, Unity 3D? Okay, so Unity 3D is a game development software, and Entity Component System is quite popular in game development and is used by softwares like Unity. So all the objects in the scene are basically entities which are inherently empty objects. And then you can attach components to these entities to add appearance, behavior, or functionality. So this is an easy way to build up different kinds of objects, and it suits the world of WebVR really well. So these are some of the components that ship with A-frame, like position, rotation. And if in case you were worrying about having to build something like the Eiffel Tower with just cylinders and boxes, you can put your mind to ease because A-frame comes with different components like object model and collada model. And with this, basically, you can import the 3D models that have been created in any 3D software and import them to your WebVR scenes. So extensions like .dae, .obj for object files, and .mtl for material files work really well. And since A-frame is quite extensible at its core, the community has filled the ecosystem with tons of components. And these components can do whatever they want. They have superpowers. But basically, they have full access to 3JS and the web APIs. And the component ecosystem is the lifeblood of A-frame. You can simply drop these components and you can use them as script tags straight from HTML. So this is an example of advanced developers empowering other developers and working on collecting these various components. These components are collected and are made available in the A-frame registry. So it's like a store of components that a registry team makes sure works well. People can browse and search for components or install them. Okay, enough talk. Before we move on, I would like to request you to kindly close your eyes for 5 seconds and recall your earliest memories of Pokemon. It might be when you watched them as a kid or watched them with your kids, or if you're like me, you probably got hit by something playing Pokemon Go. Okay, so let's take a look at a WebVR demo. My friends in the back row, is it visible? Okay, cool. They nodded, that's good. Okay, so we start with the script tag. So we include the minified version of the A-frame library here. And then we get started with the A scene, and that initiates the WebVR scene. Here I have added a component called fog. So what it does is it basically surrounds the objects at a certain distance from the camera in fog to make things seem more realistic and to give an impression of horizon. So these have different settings as well, like what's the type of fog, what's the color. Then I have used something called asset management system. So it's really useful for making your WebVR scenes much more performant. And it basically preloads all the different models to make it much more faster. And here I have added basically all the Pokemon models I could find online. And they have been included in .dae format. So here I have added some images which I have basically used as textures for the floor and the walls and included that in the asset management system as well. And then I started placing these different entities all around the scene. So first of all, I have included the Pokeball. So you might notice that I've used the attribute scale because sometimes when you are going to include 3D models in your scene, they might come up either too big or too small. So you have to kind of scale them down to fit your scene sometimes. And then I have added an animation to it so that the Pokeball rotates 360 degrees about its central axis. And then I proceeded with placing the various Pokemon models all around. And then I used the primitive model of box that we talked about a few slides earlier. And it basically, I have added a texture of so that it looks like a stone wall. And finally, we have the plane on which everything stands. And we have added the texture here as well and asked A-frame to kind of repeat the texture 40 times over length and breadth so that it does not get pixelized. And finally, the sky, and I added a slight light blue color for that. Let's see what that gets us. So as we can see, it's quite everything what we expected. We have the Pokeball rotating in the center. We have different Pokemon models here. We have the plane, and it has a texture of grass on it. Then we have the primitive boxes, which have a stone wall texture on it. And I see Pikachu here. And if you're on a mobile device, what you can do is you can move your screen from different directions to change your field of vision, and you can point at different places to kind of move about the scene. If you're on a laptop, you can use the WASD keypad to move around and use your mouse cursor for changing your field of vision. If you take a look on the bottom right side of the browser, you will see there's a goggles icon. So when you're on a mobile device in a compatible web browser, when you click on it, it kind of splits the field of vision into two so that you can put your device within cardboard. Now, if you remember the code that we just saw, you might say that, but Tane, you included positions as 10.719. This is too precise. And like this kind of experimentation, of course, would take a lot of time because you have to test something and then try it out on the browser. But to make prototyping easier and to make these things go ahead faster, A-Frame introduced something called A-Inspector. So you can invoke A-Inspector in your WebVR scene by pressing Control, Option, and I. So this opens up the A-Frame inspector. If you see here on the left panel, you have various options, and you can see the various entities that have been included in the scene. And we see the scene as well along with the grid. So on the top right, you can see options to move, rotate, or scale and model that has been included on the scene. So what you can do is pick up any model which exists in the scene, and you can move it in a different direction, rotate or scale it. Now, once I click on this model, if you see on the right-hand side of the screen, you see all the position, rotation, scale data that is attributed to this object. Also, you can see where the model is actually being loaded from. So I can make changes to the models from here itself. And we have Pikachu there. So once you have made changes to this, you can go up here on the top left and basically export the changes that you have made in the form of a HTML file. So this makes prototyping really easy because you just have to drop in some models, which also you can do it from the inspector itself, and you can position it in a way that you want. So just a quick question, like if you see here, there's two Pikachus, why is this one bigger than the other? Yep, perfect. Yeah, so like we talked in the beginning, this has been scaled because the Pokeball model was actually too small in size. So this model is scaled. All right. Moving on. Since A-Frame is based on HTML, it is compatible with all existing libraries and frameworks. So it is compatible with, for example, React.js, AngularJS, D3.js. And playing in a virtual world is much more fun with friends. Here's a demo which shows A-Frame using a component called networked A-Frame. So this is also available in the A-Frame registry. So what I did here was I opened up two sessions, one with my laptop and one with my mobile. And this is a simulation of conference room just like this, a bit smaller. So that's my player with mobile. And once I tap on my screen, it gives me feedback. And if I put it down, it looks down. If I put it up like this, it looks up. And of course, tapping on the screen gives me feedback and it waves at me. So what it does here is it establishes a full duplex connection, and it syncs using Firebase between various sessions that have been opened, and it syncs all the rotation and position data across various devices. So it also has adapters for WebSockets, DeepStream Hub, and other real-time databases. So anyways, coming back to the story, I was quite happy with the WebVR application that I made. It was working and it had Pokemons in it. But then I thought to probably take a step back and think about the term virtual reality and what that means. We are trying to emulate something and in such a way that it looks as real as possible. Okay, we can probably use high quality models which look almost real, but that would cause an issue with size. But then when I was thinking about this, I came across something called Pokemon Go. This was much better than WebVR or what I was doing. It basically looked like the real world, and that added a layer of information to the real world. So AR, that seems like the real deal. I should make an AR application. And I did some more research and came across ARJS. So what ARJS does is it basically adds a layer of information to the real world, which somehow makes things seem even better. So ARJS had seamless integration with A-Frame. And this is how it works. So ARJS comes with a couple of preset markers, which look kind of like this. There's a thick square border, and there's some text or pattern within it. So once you take your camera and scan it, what it does is it displays the 3D content that you want it to display. And it comes with a couple of preset markers. Hero is just one of them. So let's take a look at what we have here. So I have included the ARJS library, the A-Frame library, and then we define what kind of marker we would be using in a marker. So I have used the preset of hero, and then we add the content that we want to display once this pattern has been recognized by ARJS, and we include it within a marker tags. So this seemed quite interesting to me, and I really wanted to create a demo, a similar demo, which has Pokemons on it. So I went ahead and, my cursor is lost. Okay, there it is. So it's a similar example. I have added both the ARJS and A-Frame.js libraries. Then we have the asset management system of A-Frame. And then I have used the preset marker of hero for recognition and similar models, which is basically a Pokemon rotating about its central axis and 4 different Pokemons facing each other around the ball, like it's a campfire or something. Let's see at what that gives us and how that actually looks like. All right. So it asked me for permission to use the web camera. Now you can see me. So what we do now is take the hero preset marker, and once you put it near to the screen, it recognizes that marker and basically pastes the models that we want to display. So here we have a Pokeball. We have 4 Pokemons standing on the 4 sides of it. And this is kind of how it works. So it works better if you have the kind of camera on your mobile and you have a marker on a phone, then it kind of has a better effect. How many of you have heard of GLTF file format? No? So in popular media, GLTF file format has been kind of described as the JPEG for 3D objects. So it basically has 3D objects have 3 kind of files in GLTF format. So one of them looks like a JSON file, which is .gltf format. One of them is a binary file, and then it has other assets for the 3D model. So it basically reduces runtime and it packages the 3D assets so that they're smaller in size, and it's quite performant. It's more performant with A-Frame than DAE or .obj models. So if you take a look here, I have added the ARJS file, I have added the A-frame file, and I've also added another component or library called A-frame extras. So you can find that in the A-frame registry as well. And in the asset management system, I have included the .gltf file, which is basically an animated object. So I have used A-frame extras because I want to bring along the animation that this model brings to the scene. And then finally, we have the marker preset of hero and the GLTF model. And I have added the animation mixer component here so that it brings along the animation that it has. So let's take a look at what that gives us. Okay, similar screen. So when I place this here, okay, it's a bit dark, but you see a 3D drone, which basically has animation now. So you can also basically bring along the animated objects and include them in your AR or VR scenes. All right. So I was in the process of, trying to emulate Pokemon Go so that things are much more interesting. But using just the present markers, preset markers, is not that scalable or personalized. Like hero, what does that even mean? It's probably a character from Japanese language. But I wanted to create a game with my own personal markers, and I needed quite a lot of them. So the great thing is that the creator of this library has provided us with a tool where we can upload our own image, and it generates a marker and a pattern file. So you can upload an image with your name or some kind of pattern that you like in an off-white background though, and it will generate the marker and the pattern file. So if you, just a quick note of caution on this, if you go ahead and try out one of the tutorials for this, make sure that the library version is up to date, because there are some tutorials, official tutorials, in which the library version is not current. So that will cause an issue with rendering the custom markers. Well, this kind of suited what I wanted to achieve, and I created my own marker and a demo with it to see how it works, basically. So if we take a look at the code here, everything is pretty much the same two libraries, asset management system where I've included a contact card. And then we have, instead of a marker, we have a marker camera. It's not a preset anymore, so it's custom. It has the type of a pattern, and I've pointed to the direction where I have stored the pattern file. This file is generated by the tool that I showed you before. And let's take a quick look at what that gets us and if it works. Okay, now you see me again. So if I use the hero marker now, you'll see it does nothing because it's not looking for the hero marker. So my second marker is basically the same thick squares, which is kind of characteristic of that, and my name written in it. So when I take this, it kind of takes a contact card that I created. It's a PNG or a JPEG file with my photo, my Twitter, and my name on it. And while you are making these web apps at scale, it's really important to make sure not to include all the Pokemon models that you find in a scene there, but to make it performant. And performance is a crucial part of any web application. So A-frame allows you to monitor the stats of your application simply by adding the stats attribute to the ascene tag. So as you can see here in the video, I activated the stats function here, and it gives me stats of various metrics like frame per second or frame rate, and aim for a stable 90 frame per second for the WebVR 1.0 API. It shows you how many textures are in the screen, how many programs, geometries, vertices, faces, calls, load time, entities. So you have to, like, for example, if you look at entities, it should be reduced. This has a lot of entities, so it's not that performant, as you can see with the red signs there on the stats. Just one more quick question. How many of you have used Google Tiltbrush before? One. Okay, so let me give you a background on what Google Tiltbrush is. So with devices like HTC Vive, with sensors in a room scale environment, you can basically take two controllers and can paint in 3D. So Google Tiltbrush comes along with HTC Vive, and this is kind of an off-topic slide, but I wanted to show you how powerful A-Frame is. And to demonstrate that, the MozVR team constructed a 90 plus frame per second room-scale Tiltbrush experience in a few weeks with just A-Frame. So in a nutshell, VR is fun, and A-Frame makes developing VR content fun. So this concludes my talk. We discussed the various components that can be used to make a multiplayer game with WebXR, such as models in A-Frame, animating them, adding multiplayer capabilities, and leveraging AR capabilities. You can also utilize the many libraries that you can find in the A registry, such as adding physics to your scene. This will allow you to create a game, for example, in which there are multiple markers hidden around a conference venue, and when you scan it with your phone, you basically get an animated Pokemon running around. You can throw Pokeballs at them, and the physics library takes care of the collision detection. And of course, the scores would be synced across various different players. I can't wait to see what you all are going to make of it. Spasibo.
Hello, thank you for your presentation. I have one very important question. As you know, it's very hard to implement complex logic with object on the JS. Is it any implementation on TypeScript? It's my first question. And the second question, how, if we compare these two libraries with IR and VR library on Unity 3D, which is more convenient?
So I would say that it has kind of two sides to the answer, two sides to the coin. So answering your second question first, yes, they are quite performant if you make using Unity, especially if you combine it with something like WebAssembly, they become quite performant. But A-Frame has a different use case, as well as a different kind of audience, which is aimed at people onboarding. Towards WebVR. So I would say that A-Frame can handle things up to a certain level, to a certain degree of complexity. And A-Frame itself, as well as WebVR API, is quite new. So it's maturing as time goes.
Okay, thank you for presentation. Please, the question is there any way to compile the HTML for security reasons to not be hacked?
So like the browsers kind of take care of a lot of things. So with A-Frame, for example, is just an encapsulation of Three.js and WebGL. So from this code, you basically cannot get out of that DOM sandbox, and the browsers have the security implementations in place. For just as an example, you might see that I was serving files locally here. So if you try to deploy it to a server, it won't work because it has to be served over HTTPS. So just like any other HTML or JavaScript framework, it has kind of the exact same considerations.
Hi, thanks for your Pokemon example. I'm a fan of Pokemons too. But here's the question. Is it possible to make 3D graphics, maybe with models in Canvas element? Is it much performant, I mean?
I wouldn't say so, because like underlying engine is WebGL, and like especially with new browsers coming in like Firefox Quantum, WebGL has become much more performant. So it does have some GPU considerations when it's running, but as long as it's not too graphic intensive, it works out pretty much fine on like non-complicated models.
Thanks.
Yeah. What's your favorite Pokemon though?
Mewtwo.
Nice.
Hello. So as I've seen, it's like the A-frame is kind of a prototyping library, right? So the prototyping framework. Are there any plans to make it something production ready? Like I don't know, for example, the Unreal Engine or the Unity are quite performant when run on the WebGL with the very complicated models.
Yeah.
Very complicated scenes, but I've seen here the performance is quite low compared to these.
Yeah. So like as I mentioned before, A-frame is still quite young, and I think like it was very recently it reached the 1.x something, like a stable version. So like there's a full-time team on Mozilla called Mozilla team.
Yeah,
working on that.
I understand that there are improvements, but are there plans to make it something for production, or is it going to stay the prototyping framework?
No, it won't stay a prototyping framework. Like there's quite some efforts on multiple phases, on the WebVR API phase, on how browsers support these things, and also like coming with new browsers like Quantum and Reality. So yes,
Alright,
there's plans.
thanks.
Yeah.
Other questions? Thank you, Tanai. I have
Thank
one
you.
question about the future of virtual reality. What do you think about the time when virtual reality will implement in our real life?
I would say that for games, especially if you compare them to desktop games, it still has time to go, because I think last week I tried out Oculus Go. After 1 hour, I had a headache. So those things need to be taken care of. But if you look at other applications, like I saw a really good example of education and WebVR. So there was in a science book a molecule of hydrogen, and when you scanned it, it kind of showed its 3D structure, or what it's simulated to be look like. So there are other areas of interest which I would say would probably proceed faster as compared to gaming as of now.
Yeah, thanks.
Thank you, Tanay. By the way, can we get your examples somewhere on GitHub?
Yes. So is there? I think there's a group on Telegram channel, right? There's a channel.
Um, yeah, you
So it's
can send
published
the link
on-
to us, and we will
Yeah,
publish
it's
it. Yeah.
out on GitHub right now, so I can send you guys link. Right. Thank you.
Yep, cool. Thank you again. Танай Пант. Ну что, друзья, теперь... Лена, мы будем награждать друзей? Tanay, we have another action for you. You should pick 3 questions, the best 3 questions.
Okay, I have a short-term memory, but this was a really good question about prototyping and the future. The question on security was pretty important, I feel. And yes. Perfect.
And yes.
Thank you, Tanai.